Welcome to episode 8, Making Decisions. Every program we've written so far runs top to bottom, every line, every time. Today, that changes. Conditionals let a program decide what to do based on the situation. So you can have different branches depending on what the situation is. So a flowchart would be the typical example. If something is true, go down this path. If something else is not true, go down this other path. That kind of thing. So this is if then statements and variations of that. So we met the Boolean type in a previous episode, Booleans being true and false. And you get true and false through comparisons. So let's suppose we have x is equal to 56. That's an assignment, not a comparison yet. And then a comparison could be, is x greater than 50? True, it is. Is x less than 50? That is false. Is x equal to 56? That's true. Something we should notice, in the first line I have up here, the single equals is an assignment. So the line is taking the value 56 and assigning that to a variable called x. When I'm asking the question, is x equal to 56, I use a double equals. So this double equals is implicitly a question. Just like when I say x greater than 50, I'm asking, is x greater than 50? Or is x less than 50? Here is x equal to 56. Is it true that x is not equal to 56? False. A double negative in there. Think about that for a second. Is x at least 56? True. Is x no more than 55? That is false. Now let's look at if statements. So an if statement will run a block of code, so a single line or multiple lines of code, only when a condition is true. So let's say age is equal to 29. If age is at least 18, print you are an adult. Else print you are not yet an adult. So if the age is 29, is the age at least 18? Yes, it is. Print you are an adult. We're done with this if then statement. If age is 5, if the age is at least 18, it's not, so we keep going. Else, print you are not yet an adult. So that's what we have. Notice the colon and the indentation. The indented block is what runs if the condition is true, in this case, line 4. If it's not true, then it falls in the else statement, and it will run line 6. When the if statement has been run with whatever path it has gone down, then the program continues. So now we do the next part of the program. Okay. So it runs through the if statement. It printed out this line. It executed a line on line 6, and it printed that out. Now we're done with the if statement. It keeps going. This print statement is at the same indentation level as the if. That's how we know that we continue. For more than two outcomes, you can chain conditions with elif, which is short for else if. So what do I mean by that? Let's say the score is 84. If the score is at least 90, then the grade is A. Else if score is at least 80, the grade is a B. Else if the score is at least a 70, then the grade is a C. Else colon, the grade is an F. And then we'll print the grade. Okay. So we assign a score. If the score is at least 90, do that. If it's not, go to the next line. Is the score at least 80? If it is, then the grade is B. If it's not, then keep going. If the score is greater than 70, then it's a C. Otherwise, catch-all bucket for any of the conditions that did not happen happens in the else, and the grade is F. In this case, the score is 84. Is it at least 90? No, skip that. Is it at least 80? Yes. So the grade is B. Skip the rest of it. Print it out. The order in this case matters. So 84, it's greater than 70, grade is C. It skips the rest of it and then prints it out. Okay. So when we're stacking categories like this, it's important to watch the order. You can combine multiple conditions with and, or not. So let's say score is 84. Attendance is 0.95. Let's say if the score is at least 80 and also the attendance is at least 90%. Then we'll print honor roll. Okay. So the score is greater than 80. The attendance is greater than 90. Both of these conditions are true, so it prints out honor roll. If the score is 75 and attendance is greater than 95, we see the score is not greater than 80, so it stops right there and it won't print anything. I guess I could put an else statement in here to make this more explicit. Print. Sorry, no honor roll for you. Okay. Score was not high enough. It has to be both of these because of the and. For the or, if one or the other condition or both are true, then the combined statement is true. So let's say the pH is 9.2. If pH is less than 6.5, or if pH is greater than 8.5. So these are mutually exclusive. So in this case, it couldn't be both of these. And print pH out of safe range. Else print pH in safe range. Okay, so the pH is 9.2. Is it less than 6.5? No, that's false. Is it greater than 8.5? That's true. So false or true is true. If true, print pH out of safe range. Let's say it's 6.0. Okay, then it's less than 6.5. It's not greater than 8.5, but it only needs to be one of these. So now it's out of safe range. Have something in the middle there, 7.7. Then it's in the safe range. A not in OT just takes the opposite of the true or false value. So not true is false, not false is true. So I could say is failing equals false. If not is failing. Print on track. Demonstrating a syntax error. Okay, is failing is false. If not false is true. So if true, then execute the lines on the block under the if, and that says to print on track, which it does. There's something called a short circuit evaluation. So let's say x is 0. If x is not equal to 0, with spaces to make it a little more readable, and 10 divided by x is greater than 1, print big ratio, else print not a big ratio. Okay, so at first glance, it might not seem that a whole lot is going on here. So x equals 0. If x is not equal to 0, well, it is 0, so that's false. So it skips this line, goes to the else, and then executes the lines under the else. But notice it never bothered to evaluate this 10 divided by x greater than 1. How do I know that? Well, 10 divided by 0 would give me a 0 error, but we didn't get a 0 error. Why not? Because it never evaluated that. That's because of the short circuit. So what the short circuit means is that the if statement is only evaluated until we know the answer, and then we stop. So if x is not equal to 0, but it is equal to 0, so this is false. If false, that's enough to know. I don't have to bother with this and. Okay, let's end with an example that categorizes a temperature reading. So we'll say temp F is 28. That's temperature in Fahrenheit. If temp F is less than equal to 32, the category is freezing. Else, if the temperature in Fahrenheit is less than 50, category is cold. Else, if the temp in Fahrenheit is less than 70, category is cool. And else, the category is hot. And then we will print the category. So this is a common use case for if statements. Take a value and convert it to a category, bucket it in some way. So in this case, the temperature is 28. Is that no more than 32? Yes, so it's freezing. So we're done immediately. Let's say the temperature is 95. Is 95 Less than equal to 32? No. Is it less than 50? No. Is it less than 70? No. So it ends up being hot. Conditionals are how programs make decisions. We saw if, else, comparisons, and combining conditions with and, or not. This is the logic layer of Python or any programming language. Next episode, we'll look at loops, how to repeat an action without writing the same line 100 times, 1,000 times. A link to the GitHub notebook is in the description. If you like this video, please like and subscribe. Thank you. Happy programming.